So we're about to start transformations, and for transformations, in order for us to understand certain changes to the quadratic function, so in order for us to understand whether it's been stretched or compressed either vertically or horizontally, we have to know what the quadratic parent function looks like. So we're going to start, we're going to actually just look at the pattern of the quadratic function. It's not going to be a ton of notes. It's just, something that we need to know in order for us to actually fully explore transformations. So first of all, I want to kind of remind you of how we do, how we build a table with linear functions, okay? And you may not realize this is what you're doing, but this is actually how we can build out a table, okay? So I'm using a different pen here. Okay, so first of all, if my slope, so let's say I have a table, I've got 1, 5 on this table, and I want to build out more points on it. Actually, let's do that a little differently. Let's put my 1, I'll use this one because it's darker. Let's put my 1, 5 here, and then I can build points in both directions, okay? So my slope is 3, and I have a point 1, 5, and I want to build a few points on this table, like a couple going that way and a couple going that way. So I know my slope is 3 because I told you it was. So that's going to be delta y over delta x, which means 3 over 1. So what that means is my change in y is 3, my change in x is 1. So if I want to find another point, I have to add 3, which is 8. I have to add 1 to the x, which is 2. Okay? So I use the slope, change in y over change in x. So I added the change in y, I added the change in x. I could do that again here, change in y, so I add 3, 8 plus 3 is 11. Over here I change in x is 1, so 2 plus 1 is 3. So I can build more points. Likewise, I could go in the other direction by doing the opposite of that. So if I add 3 to get this way, I'm going to subtract 3 to get that way. 5 minus 3 is 2. 1 minus 1 is 0. I could do that again. 2 minus 3 is negative 1. 0 minus 1 is negative 1. So that's how we build out points. If I know the point and the slope, that's how I can build out more points if I just know the slope. And we do that on the graph by doing the rise over run. So in this case, I'd put a dot at point 5, I'd rise 3, run 1, rise 3, 1, 1, and I'd find these same points, but I'd find them on the graph. Okay? So that's how we build a table in a linear function. Now, I want to give you a couple of reminders. Now, you don't have to memorize this. Okay? This is on your formula chart. So y equals a, x minus h plus k, x minus h squared plus k. That is on your formula chart. You don't have to memorize it. We're going to use this form to kind of introduce us to transformations tomorrow, so I want you to make sure you know that. This we talked about in our, what's it called, in our linear key features notes. We talked about how the vertex is hk. So if I look at this form, the vertex is the opposite of h, and just like whatever k is. So if this was like 5, x minus 2 plus 5, it would be 2, 5 as my ordered pair for my vertex. So we're going to really get into this tomorrow. It's just a reminder, okay? So let's actually look at this pattern of quadratic functions. So the way, now there's a little bit more to it than this, but all I need you to be able to do for tomorrow is tell what the parent function looks like. So this says you find the vertex and graph it, so we're going to put a dot there on the vertex. So the vertex of the parent function is 0, 0, of the quadratic parent function. Now, there's not a lot of space here, so I'm going to talk about it. So what you do, in the parent function, it opens upward. So to get to the first point, I'm going to add 1 to my x. I'm going to add 1 squared to my y. So 0 plus 1 is 1, 0 plus 1 is 1. So that seems kind of dumb, like y squared 1. To get to the next one, for my y, to get from 0 to 2, I have to add 2. To get from 0 to the next one, I add 2 squared. So 0 plus 2 squared, which is 4, is 4. To get to this point, the next point is 3 away from 0. So to find the y value, I have to add 3 squared. Okay? I know you're like, but yeah, this is already on your table. Well, let's take a look. Let's see if we could find the next point. So this one, the next one is going to be 4. Well, I have to add 4 to get to that point. So over here, I would add 4 squared, which is 16. Now, if I wanted to find the remaining points, I would just continue the pattern backwards like they have here, and then I would connect up my pairs. right? So this one would be negative 4, 16. All right? So again, the pattern is, so if we were to write this down, 0, 0, and this is my vertex, whatever my vertex is, I add 1, I add 1 squared. I add 2, I add 2 squared. I add 3, I add 3 squared. I add 4, I add 4 squared, and so on. That's the pattern of the quadratic function. So what does that look like on the graph? Well, I start at the vertex, I go over 1, up 1 squared. Over 1, up 1 squared to build my first symmetrical point. Let me zoom in on this. Okay, for my second one, I go over 2, up 2 squared. So over 2, up 2 squared, which is 4. I go over 2, up 2 squared, which is 4. For the third one, I go over 3, I go up 3 squared, which is 3 times 3, which gets me up to 9. Over 3, up 3 times 3, which gets me up to 9. And if I could plot it, I go over 4, up 16, because 4 times 4 is 16. And then that is my parent function. Now, why do we need to know this? Well, tomorrow in class, we're going to be looking at parabolas, and we're going to be trying to figure out, is this wider or narrower than the parent function? Did it get stretched? Did it get compressed? Well, in order for me to know whether it got stretched or compressed, I got to know what the parent function looks like. So I can't tell if this thing is steeper or flatter than the parent function if I don't know what the parent function looks like. So we are going to use this tomorrow. Any questions you have about this, you need to make sure you ask me when you come in.